Kia ora, it's Mrs. Kenton here again. This time for 2 Chemistry Redox, we're going to talk about how to work out which species are the participating species and which species are the spectator species. So first of all, you have to identify the observation colours that are given to you. So we start with silver solid and a blue solution. The silver solid becomes coated with an orange solid, and the blue solution becomes colorless. So once we work out everything that's there, then we can go to the species. So we're looking at an iron nail, so that's a solid Fe. And we look down on our special chart that we've been given, and these are the 3 Fe options we have. There's only one that's solid, it's this one here, FES, and we know it says it's silver grey, so it matches the observation that we were given there. So we start with Fe solid, and it is a silver grey in colour. Then it says that the silver solid becomes coated with an orange solid. So what we have as an option is it copper that coats it, or is it the sulfate that coats it? So first of all, we go to one or the other. Let's choose copper. Here are the copper options in this chart right here. One of them has an orangey pink option, and it's a solid, so it's a pretty good thing that that's what it's going to be. So at some point, if we draw some arrows in here, the copper sulfate that we start with goes to a copper solid, and it's orange. What did it say in the orange solid? Okay, so it's an orangey pink color. And so this is the coating that forms on the outside of the nail. So now I know that it's the copper that is participating and the sulfate is not. For the iron nail, there's only Fe present because it's Fe solid, so it must be participating as well. Now, the copper started with a blue solution, and so when we look at the copper options, we know that this has a blue option and it's aqueous, AQ, so that means it's in solution. So it must have been blue. Okay, so this must be one part of it, and the other part says that the solution becomes colorless. So if we look at our Fe options, for solutions, we've got 2 that we might use, and so both of them are very pale, and if you can't decide which one to use, sometimes it's quite good to look at the oxidation numbers of what you've already got. So this is going to have an oxidation number of 0, this is going to have an oxidation number of +2 and 0, so this reaction here is reduction, which means that this reaction must be oxidation. Okay, it can't be anything else. There can never ever be 2 reduction half reactions or 2 oxidation half equations. They always have to be opposite, always, always. So what we can do now is going back to the Fe, we've got these 2 options here. If this is going to be oxidation, the oxidation number has to increase. And if it goes from Fe solid to Fe2+, then it's going to go from 0 to 2+. That's an increase. If it goes from Fe solid of 0 oxidation number to Fe3+, that's also an increase. So for this example, I would say it doesn't matter which one you choose. So let's just choose this one. Okay, and our oxidation number will be +3, which shows an increase. And although this said it was colourless, if it's +3, in fact, it would be very pale orange. But as we know, which we've seen in the lab ourselves, it is extremely pale and could be considered colourless. Okay, because it is so pale, it's very difficult to see that. So there's one example of how to work out which species is the spectator. This one's the spectator because it didn't change color. The other observation you might make, other than a color change, is a solid appearing or a solid disappearing, or a gas being made, which would show by fizzing. So those are the things you need to be paying attention to. What